Hello Science 8. Today we're going to get started on the chemistry unit. In this chemistry unit, we're going to be talking about chemical reactions, uh, what makes certain types of matter different than other types of matter. We're going to talk about what matter is, and we're going to talk about the atom. So what we're going to get started with first is we're going to discuss a little bit about what matter is. So matter is anything that has weight, otherwise known as a mass, or takes up space. So as you can imagine, that kind of makes the expansion of exactly what matter is pretty large. So matter comes all the way from anything like a solid object, like a hammer, bulldozer, jackhammer, an apple, all the way to liquids, soup, juice, beach water, river water, fresh water. All of that includes matter. And different gases. So clouds in the sky, steam from your soup, candle fire, etc. So you may be wondering, am I matter then? And yes, you are in fact matter. So humans are matter because you do take up space and you do have a mass or a weight. For example, if you were to fill up your bathtub all the way to the top and then step in the bathtub, what would happen is the water would overflow outside of the bathtub. This is because you are taking up space in the bathtub that the water was originally taking up. So you do, in fact, take up space, and that water needs to be displaced because you have entered the tub. When we're talking about matter, we usually talk about two different things. When we're describing it, we talk about the physical properties of that piece of matter, and we also talk about the chemical properties of that piece of matter. So physical properties are characteristics of matter that can be observed or measured without changing its chemical identity. So if I look at a piece of matter, these are my basic observations without doing any sort of chemical reaction that I can observe about it. So I could measure what point it boils at. So water boils at 100 degrees Celsius, but gold boils at a different temperature. I could observe its color. I could observe its resting temperature that makes it what it's at a solid. Luster, is it shiny? Hardness. For example, steel is quite a bit harder than aluminum. I could look at the volume of the matter I have, the mass, and the size. And the density, which we'll talk about a little bit today, what exactly density is. I could also look at the chemical properties of the matter. So for example, this would be things like how reactive it is with other chemicals or other forms of matter. So zinc will start to bubble when it's combined with an acid. So reactivity, so something interacting with another thing that causes a reaction. Flammability, so can it catch fire easily? How does it catch fire? Sulfur, for example, burns in the air. And then oxidation states. So what happens to this piece of matter when it interacts with oxygen? So for example, iron after a while will begin to rust because of its reaction with oxygen. An apple, if you cut it in half and left it on your counter, it would soon begin to brown, and this is again because of oxygen. So chemical properties, again, are characteristic of matter, and they can only be observed in a chemical reaction. So it's something that you can see or notice, but it has to be occurring during a chemical reaction. So something reacting with something else. So chemical properties are described as the ability of matter to react. So for example, if I was looking at baking soda has a white color. It's not shiny. It's very soft and powdery. I could measure my baking soda. I could look at how much volume of baking soda I could put in a container. I could look at the size of the grains. Chemical properties of baking soda, for example, baking soda is a base and it reacts with acids. So if I combine baking soda with vinegar, I could look at that reaction. So that would be chemical properties of baking soda and physical properties of baking soda. We're going to spend some time looking at physical properties today, but we're going to come back to chemical properties later. So physical properties, we're going to look at three main ones today, one being volume. So volume is the amount of space that an object takes up. So if I poured a can of Coke into this graduated cylinder, that Coke would take up a certain amount of space in the graduated cylinder. And I could use that to measure it. So typically we measure volume for gases and liquids in liters and milliliters. So those are metric forms of measurement. So I could measure a gas and liquid, the volume of it, by using a graduated cylinder, a beaker, or an Erlenmeyer flask. Solids are a little bit different. If I dropped, for example, say the top of my Coke bottle, like a bottle cap, inside this Erlenmeyer flask, I can't really measure the volume of it because it wouldn't take the shape of the container, which is what we'll kind of describe as the difference between liquids and solids a little bit later. But the bottle cap wouldn't take the shape of the container, so I'd have to measure it in a different way. If I was looking at a regular object like a cube, then I can use this form of measurement. If we're looking at irregular shaped objects, there's another form of measurement that we're going to discuss. So solids, typically we use base units of meters cubed, so cubed being width times length times height. So that's why we get that 3 up there, because we're taking these 3 measurements and we're multiplying them. So your base unit or unit that you could measure this in would be either in meters cubed, so M3, centimeters cubed, or millimeters cubed. You can calculate volume of regular objects by multiplying length times width times height. So that's how I get this volume of a square object. And we'll do a little practice. So here's 2 cubes. I've already labeled what each of these are. So I've got my length, I've got my width, and I've got my height. First thing I'm going to do is write down my formula. So volume, I can find this by multiplying length times width times height. So I plug in all these numbers. I've got my length, I've got my width, I've got my height. So 6 centimeters, 3 centimeters, 2 centimeters. It's important that you write these units here, and I'll show you why in a moment. So I'd take these numbers, I'd multiply them. So 2 times 3 is 6, 6 times 6 we know is 36. Don't hesitate to use your calculator though, there's absolutely no shame in that. So volume equals 36 centimeters cubed. How did I get the cubed? I've got 3 centimeters here, that's why it's cubed. So again, just another quick example. If I wanted to find the volume of this cube, so again, how much space it takes up, I would multiply the length, the width, and the height. So I'd take in these numbers, so 8 centimeters, 4 centimeters times 2 centimeters, plug them all in, and then multiply. So 2 times 4 is 8, 8 times 8 is 64. And then we've got our centimeters cubed because we've got 3 centimeters there. Typically, objects aren't going to be very regular. So one way we can measure their volumes is through displacement. So what you can do is you can calculate the volume of an irregular shaped object by measuring the amount of water it displaces. So if I drop this rock into this thing of water, what's going to happen, similarly to this bathtub, is the space that the man is going to take up is going to be pushing all of that extra water outside of the bathtub. So the space that he is using can no longer be filled with water, so he's displacing it. So in this case, the rock is pushing all of the water out of the beaker into this nice little beaker over here. So it's collecting the water, so we can measure the water that's being pushed out by the rock, and this will actually be the same volume as the rock will be. So for example, this could be 30 milliliters and this would be 30 milliliters in terms of volume. Another quick example, so if you place a large screw into a graduated cylinder with 60 milliliters of water and the water level rises to 80, what is the volume of the screw? So the screw, again, we can't measure it, so we drop it into the graduated cylinder and then the water is going to rise to 80 milliliters. How we know what the volume is of the screw is we are going to take this difference. So we're going to minus 80 minus 60 milliliters. So take the difference of the increase. So how much did it go up by? Which is 20 milliliters. So the volume of the screw is going to be the difference between the increase in volume and the original volume. Another quick little example. We've got a dinosaur here. Again, challenging to measure. So what we can do is we can measure this. I know that each of these is going to be worth 2 because there are only 5 ticks between the numbers. And I'm going up to 5.0. So this will be 4.2, 4.4, 4.6, and 4.8, and then finally 5.0. So 4.8, and then over here I've got 5.2, 5.4, 5.6. So I'm going to look at the difference between my two numbers. So I made a little mistake here because you can't go backwards like that. It's not going to work, or I'll have a negative number. So 5.6 milliliters, you're going to take the larger number and you're going to subtract it from the original number. So the difference between those new numbers, so the one with the object in it and the object not in it, is going to be what the volume of your object is. So the volume of this dinosaur is 0.8 milliliters. So we've talked a little bit about volume. Now we're going to talk a little bit about mass. Mass is the amount of matter that an object contains. So we think of this as the weight, the heaviness of the object. How we typically measure it is with a scale. This is one example of a scale. There's digital scales. There's the triple beam balances that we use to measure our gummy bears at the beginning of the year. Typically, we measure gases, liquids, and solids using grams, milligrams, or kilograms. Again, these are all metric numbers. If you were to measure a liquid or a solid, you would typically measure the container empty first, then put the container back on the scale with the liquid in it, and then subtract the weight of the container. So we talked a little bit about mass, we talked a little bit about volume, and what we're going to talk about now is we're going to talk about density. But first, I'd like you to think a little bit about what you already know. So I've listed a bunch of objects here. Which objects do you think will float? So you would be correct if you thought the wooden log, the cork, the steel hull ship, and the foam brick. So even though there are objects, that are made out of the same material, so for example, the steel hull ship floats, but the steel brick doesn't float, the reason why some of these objects float and some of these objects do not float is not necessarily about size, but is about density. So what exactly density is the amount of matter or mass in a given volume. So this is a great example right here. So these objects are the same size. They may even be made out of different materials, but they appear to be the same size. Okay, so their volume is the same, but their mass is different, and that is due to density. So this one is tightly packed. So this object is a lot heavier. It's very, very dense. Everything's tightly packed. This one over here is a lot lower density. The objects are very, very separated. So it's the amount of matter in a given volume. So these volumes are the same, but this object is less dense, less heavy than this one. I like to also think of it as pillows. If you had a pillowcase and you had a pillowcase that was filled with feathers and then one that was filled with bricks, which one would be heavier? So exactly, the pillowcase filled with bricks would be heavier. So it is a more dense pillowcase. It's filled with a heavier, more dense material, versus the feathers are going to be much lower density and it's going to weigh less, consequently, even though they are the same volume. So typically we measure density by grams over centimeters cubed. So grams per centimeters cubed is kind of the idea. So it's a certain amount of weight in a certain amount of volume. Liquids we typically measure in grams over milliliters cubed. So a typical an amount of weight within an amount of liquid. So again, which one is more dense, which one will float? These two objects are similar in size, but which one will float? So you would be right if you said the sponge. The sponge is a lot less dense than the brick. The brick has got a lot of matter that's tightly packed together, just like this high density object. It's very, very dense, lots of matter packed into the same amount of space. It's going to sink. This one, particles are very separated, less matter packed into a space. It's going to float. So what we're going to do is we're going to talk about part of your activity this week, which is going to be using the PhET simulator, and I'm just going to show you it. Okay, hello Science 8. So for your assignment today, what you're going to be doing is you're going to be exploring floating and sinking with this PhET simulator demo. If you can't get access to the a desktop computer, because this computer does need to be done on this activity does need to be done on a desktop because it uses Flash, please let me know, and I will find another activity for you. Spelled activity wrong. So this is the link for the website. You're going to open it up. First thing you're going to do is you're going to experiment with different materials. So you can toggle down different materials. And try dunking them in the water. Which materials sink and which materials float. So list each down below. I want you to come up with your own definition for the word volume and your own definition for the word mass. So based on your exploration, what do you think each of those things means to you? I want you to explore also what happens when you make volume of the block bigger and smaller. So you can slide this toggle along. Does it affect the mass? Does it affect the density? So the density is right here. So this is the amount of weight per a given volume. So how much weight per liter in this case. Does the density change? Explain why. This makes sense. And does floating and sinking change? Then you're going to design your own block. Experiment with making your own block out of your own material. So you can go my block. And then move around the different size. What makes a block more likely to sink? So what can you manipulate to make it sink? And what can you manipulate to make it float? How does this affect the block's density? You're going to test out your ideas using the objects of same volume. So you're going to toggle over to same volume and try experimenting with throwing each of them in the water. How do they float? What do you notice? Besides being different colors, what makes these blocks different? What makes a block more likely to float? And how does this affect the block's density? You're going to explore objects of the same mass. So you're just going to move over onto the toggle switch there and try moving them over. Observe how they float. What do you notice? Besides being different colors, what do they have different about them? If all the blocks have the same mass, why are some floating and some sinking? At the end, after you've gone through the math lesson that's just coming up, I'd like you to do the density equations. I want you to fill in all of the information in each of these channels. So you're going to gather the information from the question. So for example, density, mass, and volume. So volume in this case is 15 milliliters. You're going to write it in here. So you're going to plug in your information. So you've shown me that you're able to read the question, find the information. That's worth 3 points. Then you're going to plug in the information into the formula. So for mass, I'm going to type in 4.5 grams. And then for volume, 15.5 milliliters. So 3 points to show all your work. If you needed to calculate volume, you would do that in here. And then of course, you're going to type in your final answer and make sure that you have the units so you can get that second point. So these are all of the questions. They're all different questions, but they're the same type of questions that we've done today. So there's no tricks here. Everything should be gone over in the PowerPoint. Okay, so remember again, fill in all information for all of the columns. Make sure you show your work. Type into the formula. Add anything that you need to. If you need to look at, figure out volume. Okay. And again, this is kind of what the PhET simulator looks like. So you can change the mass and the volume of the object. Try seeing what it does in the water, how that affects it, how different types of materials affect it. So you got a chance to play around with the PhET simulator. Now we're going to look at comparing density. So Italian salad dressing is made out of 3 main components: water, oil, and solid flavoring. Each of those ingredients have different types of densities. And based on the one that has the lowest density is the one that's going to sit on top of that salad dressing. So think about when you go to the fridge, the salad dressing is there, you grab it, you go to put it on the table. Before you want to put salad dressing on your salad, you want to shake that salad dressing, right? To mix all of those different layers. That's because the layers will separate when they're given time based on their density. So the 3 layers that typically will come in a salad dressing, so the least dense layer will be the oil, which you'll see at the top of your dressing. The middle layer will typically be either your water or your vinegar layer. It's less dense than the oil, but not as dense as the best part of the salad dressing, which is the solid flavoring, things like pepper flakes, peppercorn, all of that kind of different kind of textural stuff that you'll get in your salad dressing. So you can kind of see in this picture of salad dressing, we've got our oil on our top, kind of our flavoring and other ingredients are floating to the bottom.
Bearded Science Guy here, and today I'm going to show you how to make a 7-layer density column. Start with an empty glass vase and begin pouring honey into the very bottom of the vase. Honey has the greatest density of any of the fluids we'll be using, so it'll make our base layer. Next, begin pouring corn syrup on top of the honey. Corn syrup is usually clear when you purchase it in the store, but mixing it with a little bit of food coloring can give it a bright, vibrant color. Next, we'll be using Dawn dish soap. It's important to avoid hitting the sides of your container when pouring the first few layers. The next layer is water dyed with food coloring. Instead of pouring it in the center of the previous layer, use a turkey baster to drip it down the side of the container. The same technique can be used for the next layer, which is vegetable oil. After that, add 91% isopropyl alcohol mixed with a little bit of food coloring for your second to last layer. Finally, cap off your density column with lamp oil. Now, food coloring won't work with lamp oil because of its non-polar nature, so make sure to get some with coloration already added. Now that you have your density column already created, you can begin testing the density of objects by dropping them in and seeing where they end up. I started this process by testing a metal screw, which dropped all the way to the bottom of the honey layer. A grape tomato, on the other hand, dropped into the bottom of the Dawn dish soap layer. A plastic bottle cap came to rest on the top of the vegetable oil layer, whereas a ping pong ball rested on the surface of the entire density column. As you go from top to bottom, the layers become more and more dense, preventing them from mixing together.
So, prior to that experiment, the Bearded Science Guy, what he did is he knew that certain liquids were certain types of densities. So you can calculate the density of a liquid or an object by using a simple equation, and I'm going to show you guys how you would go about doing that. So two factors that affect density, as we already discussed, are mass and volume, because density is the idea of a certain amount of matter being compacted into a certain volume or amount of space. So these little triangle guys, you might have used them in another math class before. Each of these letters, you've got mass, so mass represented here, we got density, and we've got volume. The way this triangle works is if you are looking for a certain answer to questions. So for example, you're looking for the density of silver. What you would do is you're going to circle this guy, and then what you're going to do is you're going to divide, so mass over volume. So that's what this little line here means. If, for example, you were looking for the mass of silver, but you knew its density, so maybe you have an unknown amount of silver, but you know how big the container is that you're measuring the silver in, and you know how dense silver is. So you could figure out mass by taking density and volume and actually multiplying them. So beside each other means you multiply. If I knew the volume for my density equation that I was looking for, so if I knew the volume, I didn't know the volume, but I did know the mass and the density of the object I was looking at, so I don't know exactly how much I have, what I could do is I could take mass and I could divide it over density. So this is a little bit how this triangle works, and I'm going to show you some examples. So calculating density. So first up, when you look at an equation or an example question like this, is to read through the question. So orange juice is tested to ensure it meets certain standards. One standard is density. So we're talking about super thick pulpy orange juice or super thin watery orange juice. If a sample of orange juice has a mass of 312 grams and a volume of 250 milliliters, what is its density? So my first step with this problem would likely to be is to put down the equation. Okay, so I have my mass, density, and volume. Okay, my next step is going to be to look at what exactly is this question asking me for. So I read through the question again. So this is, what is its density? Okay, so I'm obviously looking for density. So I can cover that up, and what I'm going to do is I'm going to put my mass over volume. I'm going to divide my mass over my volume. Hopefully they've given me this information in the question. So density equals mass over volume. So I've written down my formula. That's your first step, and I want to see this work done when you do the activity. I'm going to read through my question. So again, if a sample of orange juice has a mass, they very clearly have stated mass, but I would also know its mass because I've got this gram here. So I know the mass is 312 grams. So I can plug that right into my formula. I also know they very also clearly stated volume of 250 milliliters, but I also know that they're talking about volume here because it is in milliliters. So for my density, I've got 312 grams over 250 milliliters. So I've taken my mass, I've put it at the top, and I've taken my volume, and I've put it at the bottom. All I need to do now is divide. So I already did the math, but if you needed to use a calculator for this, that would be absolutely fine. It is incredibly important, and you will not get the right answer if these two numbers are flipped. So you want to make sure that you're carefully copying these into your formula. So the density answer that I got when I plugged it into my computer was a density of 1.248 grams. Sometimes you'll even get more numbers than this. But I'll tell you right now, you don't need this number. You can stop at 2 decimal places. So what you can do is if this number is above 5, you can round up this number. So that means go up to the next number here. So that would be 1.25 grams per milliliter. These units, where did I get them? They're right here. So grams over milliliters. So what exactly this is the density is going to be a gram over milliliter. So I have a certain amount of weight per a certain amount of milliliters. So for 1 milliliter, I have 1.2 grams of, they haven't specified exactly what the weight is, but that's how much it would weigh. Okay, next problem question. So first up again, I'm going to read the question. So what is the density of a 250 gram rectangular box that is 10 centimeters long, 5 centimeters wide, and 2 centimeters in height? I throw down my equation. So I've got my triangle. So mass, density, volume. I know that I'm looking for density because it asks me, what is the density? Okay. So now what I'm going to be looking for is I'm going to be looking for my mass and I'm going to be looking for my volume so I can solve this equation. So very, very quickly, I see this 250 grams. So a 250 gram rectangular box. So I know its mass because of the G, which stands for grams, which is how I would measure mass. So that one's nice and quick. The next thing I see is these set of numbers over here, which might confuse me because when I'm looking for a volume, I'm looking for one number, but with all three of these numbers, what I can do is I can do an equation. So first things first, throw down my formula. I've decided that I'm looking for density. I know that I'm doing mass over volume. I definitely know that this is my mass. So density equals 250 grams over this amount of volume. How I'm going to solve for volume is I'm going to multiply the length times width times height, which I have right here. So I have 10 centimeters long, 5 centimeters wide, 2 centimeters in height. So those are our dimensions that we've got. So 10 times 5 times 2, plug that into my calculator or do it by hand. To go 2 times 5 is 10, 10 times 10 is 100. 100 centimeters cubed, don't forget this cube because you've got 3 sets of centimeters. That's why there's that 3 up there. So then I can plug that volume into the bottom of my formula. So my density is again 250 grams per 100 centimeters cubed. So once I do that math, divide it out, I've got 2.5 grams, and then there should be a little slash here, forgot that, 2.5 grams over centimeters cubed. So that's 2.5 grams per centimeter cubed. So for every 1 centimeter cubed, so 1 by 1 by 1 by 1, so 1 by 1 by 1 square, you're going to have 2.5 grams of weight within that cube. That's what we're talking about. Okay, I think this is my second last question. So once again, my process. Read through the question. The density of the salt is 2.16 grams per centimeters cubed. So I've got 2.16 grams per every centimeter cubed. Okay? So if this cube was 1 by 1 by 1 by 1, I would know that there are 2.6 grams within this one cube. So what is the mass if you have a cube of salt with a volume of 400 centimeters cubed? So I've got my other number here. So go through my formula. I've got the density. So I'm not looking for density. I've got the volume, and they're asking what is the mass. So what I'm going to do is I'm going to cover up that spot where I don't know the answer. So I don't know what mass is, so I cover it up. So I'm going to do density times volume. So if they're across from each other, you multiply. So mass equals density times volume. Can plug in my numbers. Mass, I don't know what it is, 2.16 grams over centimeters cubed. You want all of these units here, very important. Then you've got it multiplied by the volume that they've given you. So I'm looking for the mass. So if it were this big and this dense, how heavy would it be? Is what I'm looking for. So I multiply them and I've got 864 grams. You might be wondering what happened to your centimeters cubed. Because we're multiplying and these are the same, what we can do actually is we eliminate these units when we multiply. So because they are identical, we're going to eliminate that. And then what we're left with is our grams, which is what you should be looking for when you're answering the question with mass. Calculating density using displacement. So a rock is dropped into a full can of water and causes 35 milliliters to spill out. So full can of water, 35 milliliters spill out. Maybe I've conveniently got this little bucket here. So I know there's 35 milliliters that this rock is pushed out. The mass of the rock is 260 grams. What is the density of the rock? So what I'm looking for in this case is I'm looking for density. I'm going to cover up it on my formula. So density equals mass over volume. I know that I've got some information here. So 35 milliliters of water to spill out. I'm going to highlight that for now and leave it. I also know that I have this number here. I know that this is likely my mass because it's got a gram next to it. I'm also thinking this likely has something to do with my volume because it's got milliliters next to it. What might make this question confusing is that water is spilling out. They haven't told me what the rock weighs, but we know that if a rock were to enter a full thing, the water that it would displace would be equal to the amount of the volume of the rock. So we know that the volume of the rock is equal to the volume of the water displaced. So what I can do is I can plug that into my formula. So I've got my mass, 260 grams, and I've got my 35 milliliters of water that is being dumped out of the container. So 35 milliliters. So I'm going to divide 260 grams by 35 milliliters. What I'm going to get for my density is 7.4 grams over 1 milliliter. So 7.4 grams per 1 milliliter is what my answer is. So I've got 70.4 grams of weight within 1 milliliter of this rock.